Hi, I'm Mark Backler. I'm a game designer at Lionhead Studios, and I'm going to be talking to you about designing natural user interfaces, or NUIs as they're known for short, which are an entirely new way of interacting with technology that utilize natural human inputs such as speech, gesture, and touch. The reason I'm going to be talking about these kinds of interfaces is because they're very much on the rise. These days, we're seeing them in our living rooms, our classrooms, and our operating theatres. But designing for these kinds of interfaces is unlike designing for any other. A lot of the traditional rules of user interface design either don't apply or require significant rethinking. I'm going to start by looking at some of the applications of NUIs. Then I'm going to look at some of the challenges of designing them. And then I'll be looking at a case study of one particular NUI device called the Kinect and how we used it at Lionhead for a particular title which was controlled entirely by a natural user interface. So a definition of natural user interfaces is actually quite hard to come by. I've looked on loads of different places, but they all seem to be really long or really contentious. But for the purposes of this talk, I'm going to be talking about the main points being that they're human-machine interfaces, that they're effectively invisible or become invisible on subsequent uses, and are based on natural elements. So an example would be your iPhone, which is a NUI device, but the actual natural user interface itself is iOS on it and the touch controls. So the purpose of these kinds of interfaces and these devices is to try and minimize the learning curve for new technology. Obviously, every device requires some kind of acclimatization, though. But with NUI devices, we're trying to minimize that as much as possible and get it down to effectively zero. So where are we seeing these kinds of devices? Well, Samsung have recently released a new line of smart TVs that feature gesture and speech controls. And pretty soon, we could be seeing them augmenting or even replacing our trusty desktop mouse. So I'm going to be talking about my experiences of developing for the Kinect, but a lot of this should be applicable to any other natural user interface and hopefully beyond. What is the Kinect? Well, essentially, it's a camera that works with your Xbox 360 and sits above or below your TV. When it was first released in 2010, it sold over 19 million units, and it broke the world record for the fastest-selling consumer device in history. This is what it looks like. It's got two infrared 3D depth sensors and an RGB camera that allow it to perform skeletal tracking and gesture recognition. It can also do facial recognition, and it's got a microphone that allows it to perform noise detection and speech recognition. It's not just entertainment that it can be used for, though. At the recent Microsoft Accelerator conference, groups of students were challenged to use it in innovative ways. One group scanned in items of furniture with it and allowed users to virtually position them around their living room so they could see how well they fitted in. Another group used it in conjunction with a projector to effectively turn any surface into a multi-touch display. There's also a vast array of medical benefits, though, such as helping to rehabilitate stroke patients and allowing surgeons to navigate MRI scans and CT scans while remaining sterile in the operating theatre. But for me, it's all about the video games. Who here plays games? Pretty good, pretty good. So I've loved games since I was little. I remember being about 4 years old and sat on my dad's lap playing on a Commodore 64 on my favorite game, Donald's Playground, which saw you taking on the role of Donald Duck, working various jobs to earn money to buy toys and playground equipment for your kids, a concept I'm sure many of you are familiar with. Maybe it's these fond childhood memories that have reserved games such a special place in my heart. But I think it's more than that. I think it's their potential. Games have the capacity to tell meaningful stories, to take us to deep worlds to teach us about the world around us and to teach us about ourselves. But as the years went by, my dad stopped playing games so much. When one day I asked him why, he told me that it was because we'd moved from this to this. Controllers are actually pretty complicated these days. Each console generation, we get a new button or feature added. And if you're a gamer, you get gradually used to it. But if you don't play games, then this becomes quite a barrier to entry. You get handed this controller with 1 million buttons on it, you don't know what any of them do, and you spend half your time looking down at the controller. So one solution to this problem from the current generation of console manufacturers is motion control. Nintendo was first to market with the Wiimote, then they were followed by Sony with the PlayStation Move controller, and Microsoft with the Kinect. All of these devices improve the demographic of video games. They broaden the market, but they also present significant challenges as developers are faced with designing an entirely new kind of interface. And the Kinect actually provides even greater challenges than the other devices because you don't have any physical hardware to hold onto at all. There's no buttons to press. But because of this, it also broadens gaming to the mass market even further. So some of these challenges that we're presented with include giving good feedback. When you have a controller, players have haptic feedback. They can feel when they press a button and they can hear it click. But with Kinect, we don't have that. So we can try and solve this in a number of different ways. Firstly, we can display the Kinect depth feed so the player can see exactly what the camera is seeing of them, so they know if they're too far forwards or off to the side. Next, we can use audio effectively, so when you're navigating a menu or selecting items, we can subtly cue these things to the player. Also, the main thing is visual in-game feedback, so here you've got a virtual set of hands so you can see what's being registered of your movement, or another example would be in a racing game, if you're steering a wheel, well, turning your hands, you see the steering wheel turn on screen. The next big challenge is choosing good gestures. You want to make sure you're using a distinctive set of gestures and that you're using the minimum amount possible at any one time, because the more active you have and the less distinctive they are, the more likely you are to get false positives and other errors. We use a brilliant tool called the Visual Gesture Builder to allow us to really easily prototype gestures. So you can just be sat at your desk, you hit record on this thing, you perform a gesture, you can then really easily drop it into game and see how well it works. The next challenge is designing a good GUI for your game. Because Kinect is still so new, there's no real consensus yet on what the best technique is. So we're still seeing lots of different methods. I'm going to be looking at a couple of the most popular ones in a couple of slides' time. One thing you do want to bear in mind with your GUI is that buttons that are to the extreme top or bottom of the screen aren't actually that comfortable for people to use. If you're reaching your hand really high up, you'll find the blood starts draining down your arm and it gets very uncomfortable. If you're reaching really low, it's hard to get your hand at the right angle, especially if you're sitting down. Another reason why you want to avoid the edges of the screen is because when you're running on a TV, you're likely to get content cropped off on certain people's sets. So you want to make sure you don't have any important information or buttons too close to the edge. The couple of navigation techniques I'm going to be looking at are cursor and swiping. So with the cursor technique, it's pretty self-explanatory. You raise your hand, you see a cursor on screen, it moves as you move. This works really well because it gives you really instantaneous feedback. It's also a paradigm that people were familiar with. Everyone knows how to use the mouse, so it doesn't take people long to understand this concept. Unfortunately, though, when you're holding your hand up in the air for a long period of time, it can get quite fatiguing. Also, there's an inherent amount of jitter in Kinect when you're tracking someone's hand. So you need to average out the cursor position over a few different frames. But obviously, the more you do this, the more latency you're going to get and the laggier the user's experience will be. So you need to try and find the sweet spot between responsiveness and jitter. The other popular method is swiping, which was used to great effect in Dance Central. I have a quick video here which shows it off. So you just navigate the menu by scrolling your hand up or down to move down this list of items. To select one, you merely swipe your hand across, and if you want to move back, then you just swipe with your left hand. So this works really well because you don't have the jitter that is inherent with using a cursor. You've also always got something selected, so a certain amount of the time, that's going to be the thing that your user wants, so it makes it quite efficient because they can just swipe straight away. You don't get the same level of continuous feedback that you do with a cursor, though, because if you're moving your hand in a direction that isn't scrolling up and down the list or swiping, then there's going to be nothing happening on screen. And because it's a new system, it takes people a little while longer to get used to than a cursor. When you're using voice control with Kinect, like gestures, there's a few things you want to bear in mind. That you want to have less than 10 phrases if possible, and they all need to be as distinctive as you can make them to avoid any false positives. Also, you want to avoid any single syllable words, but at the same time, you don't want your phrases to be too long because then you're going to get some noticeable lag when you're reading in or waiting for really long phrases. You'll also want to bear these rules in mind when you're localizing, because when you've made sure that your phrases are the correct length, you don't have any single syllable words, as soon as you translate this to another language, obviously that's all going to be thrown out. So you need intelligent localization to bear that in mind. You also want to watch for homophones because in English, two words that are completely different could sound exactly the same in another language. One of the brilliant things about using Kinect for voice is that you can just type in everything you want to listen for into a grammar file, and it will work straight away for you. You don't need hours of audio training or data logs or anything to get it working. I'm now going to look at a case study of Fable the Journey, which is Lionhead's latest title, which was built from the ground up with Kinect in mind. We didn't shoehorn it in halfway through the development like has happened with some projects, which works well because obviously it means you're planning for the hardware from day one. The main mechanics of the game involve casting magic spells and magic-based combat and traveling through the game's environments on a horse and cart. One of the main unique points about the game is, despite being a Kinect title, you can sit down to play it. We knew this would be really important because we wanted it to be a 10 to 15 hour story experience, and no one's going to want to stand up for that period of time. So we give feedback to the player in a number of ways throughout the game. This is a screenshot of one of the traveling sections where you're on a horse and cart. When you turn your hands to steer, you see the reins move, the horse will turn the direction you're going to go, and then the horse and cart will change to that direction, much like a real horse and cart works. But one thing we found when we were putting the game through user research was that this felt a bit too much of a delayed reaction for users. They couldn't tell what effect their input was having. So we ended up losing realism slightly by adding this green rein here when you make a turn. So as soon as it's registered a valid input, the rein will turn green to show you, and people found this a much better experience. For the magic sections of the game, when you raise your hand, you get a bolt of electrical energy there that will follow your hand around as you move it, so you know that you're primed and ready to cast a spell. And as soon as you move your hand forwards, it's going to fire. Like I mentioned earlier, for some sections of the game, we display a Kinect feed if you're in the wrong position. So you can see if you're too far forward, too far back. We opted to use a cursor for our GUI because we wanted that instantaneous feedback and we didn't have especially long lists of items. But one thing we found when choosing the cursor was you then need a way for people to select the buttons. And the most intuitive thing seemed to be to have people pushing their hand out. That was what everyone did to begin with, just naturally. But then we found a few problems with this. It's not actually all that comfortable to be repeating that gesture. And often people navigate the menus by keeping their hand fully extended. So then when you ask them to extend it further to press a button, it's either uncomfortable or impossible. Also, when people go to move their hand forward to press a button, it will move the cursor slightly, and you can sometimes slip off the button you were trying to select, which is quite frustrating. So we ended up going for a hover to select system. So you just move your cursor over the button, and you get a little charge icon that shows you your progress, and then it selects the button after about 1.5 seconds, I think it is. If you move it over a button you don't want, you can just move it off before it's fully charged. But obviously then you have the issue of selection speed. So you want it to not be so slow that your power users get frustrated at having to spend 3 seconds selecting every button, but you don't want it to be so quick that novice users are selecting buttons by mistake. So we tried to find the sweet spot for this, and we tweaked that value quite a lot, but we also added in a feature for users to be able to change it for themselves. Another thing we found was that when people are hovering the cursor over a button, if the cursor's jittering slightly, then it can mean you jump off the button that you're trying to select. So we added in a magnetic radius that expands over time as you're selecting the button, because the longer you've been on that button, the more confident we are that that's the thing that you're trying to select. We added some button animations, so when you move your hand across a screen of interactive buttons, they'll all move and react to your cursor. But having spoken to our sister studio, Rare, who are also developing Kinect titles, they told us that they found users didn't like this, because when they move their cursor over something that they're not intending to select and it reacts straight away, it makes them feel panicked. So again, this just shows that there's no real consensus on all of this stuff yet, but Rare ended up adding a 1 second delay to their button. So you move your cursor over it, nothing happens for the first second, then it begins to charge up and animate and everything. And yeah, they found this a better solution. One problem we found was that on certain screens, when you select a button and you're then taken to the next screen that has a button directly underneath, your cursor would start charging up straight away and you'd be selecting a button that you didn't intend to. So our solution to this was similar to Rare's, of adding in a 1 second delay each time you load a new screen. So you've selected a button, the new screen loads, it waits 1 second, which gives you enough time to see if that's the button that you want to select or not. We found that teaching gestures in a NUI device title was actually really difficult, because when you've got a controller, you can say press X to attack, and there's no ambiguity there. But with a gesture, when you say move your hand forward to cast a spell, everyone does that in a slightly different way. So we ended up using some full-screen tutorials that show the gesture from a variety of different angles. We realized that we needed to show people the gesture before telling them, because if you tell them what to do, everyone's got their own interpretation, and it will all be slightly different, so you can't rely on that. So that was why we ended up with these full-screen tutorials. Because if you do tell them what to do before you show them, then getting people to unlearn the incorrect thing is actually really, really difficult to do. Even if you do manage it, then people will often later revert back to the original incorrect gesture, just sort of under the pressure of the combat scenarios in the game, and because you're concentrating on playing the game and not necessarily that much on the gestures that you're actually doing. Another thing we found was that people tended to evolve new gestures over time. They'd have the gesture right to begin with, and then through repeatedly doing it, they'd slowly drift into an incorrect method that wasn't getting picked up by the game anymore. One solution we found for this was to try and give reminders at the corner of the screen when we notice if the player is doing anything wrong. It's got a little animation and some text describing what we're looking for the player to be doing. The problem with this, though, is that when you're looking for a set of about 5 different gestures, if the player is doing the wrong thing, you don't know which gesture it is that they're actually trying to do. So to some degree, you can tell which it's closest to, but sometimes there's just not much you can do about it, and you have to rely on either the context that they're doing it in or mind reading. User research showed us a lot of these issues, and as ever, I found that there's only really 2 times to do it: too early or too late. That period of the right time is just so small, I don't know if it even exists. Because when you go to user research really early on with just a basic prototype, you might be worried about showing this to users and they won't understand it, but actually I think it can teach you some really fundamental things that will really shape the development of your project. But if you wait until you've got a product that you're happy to show people and that you feel they'll understand, then the sorts of fundamental things that user research is going to tell you you need to change, you're probably going to be so far along that you're now unable to change them. Our user research also showed us that with natural user interface titles, people often have no idea how to use the hardware. They end up either over-exaggerating or under-exaggerating their gestures and speech. So, I've talked about some of the challenges of developing for natural user interface devices, looked at some of the different applications of them, and looked at a case study of Fable the Journey and Kinect. What can we learn from this? Well, as a game designer or user interface designer, you might find that you're out of your depth with no physical hardware. You might find you're wishing for it back. But don't worry, because as long as you're questioning the rules that you thought were true, as long as you're questioning your assumptions, then you can find out which rules still hold true and which need rethinking. Prototyping will really help you out here. It's absolutely vital, as is user research, which will show you if you're giving the right kind of feedback and if you're teaching your gestures in the right way. Natural user interfaces are everywhere these days, and they're constantly changing as well. They're getting better and better. Pretty soon, we're going to be seeing eye tracking and emotion recognition. I'm sure we're going to hear some other fantastic uses today. But we've only just scratched the surface so far. Kinect is just the beginning. These natural user interface devices are nothing without great user interfaces for them. User interfaces that will be designed by people like you. Thanks very much.